Hi, everyone. Welcome to Cybersecurity Nonprofits April webinar. We have Andy Murray with us presenting how we control and protect the grid. Really excited to have him here. I'm Marta Wang, and I'm the Education Manager for Cybersecurity Nonprofit. So I'm just going to take a few minutes to briefly introduce Cybersecurity Nonprofit before letting Andy take it away. So this is our Cybersecurity Nonprofit's mission. Cybersecurity Nonprofit is a nonprofit organization that empowers our community through inclusive and accessible cybersecurity education, awareness, and exploration. We have these 4 pillars: inclusive education, to provide inclusive and accessible security education to pursue a career in security; cybersecurity awareness, to increase cyber safety knowledge and awareness in the general population; third, diversity, equity, and inclusion. We want to promote diversity, equity, and inclusion in the cybersecurity and technical fields; and exploration, to support and encourage and lead innovation and exploration in cybersecurity and technology. We have a lot of events, presentations such as this one on many topics, both technical and career focused. We also have workshops, hackathons, panel discussions, trivia, and we're also working on some really fun interactive events to get you excited about cybersecurity, help people break into cybersecurity. So hope you can follow us, stay in contact, and we'll inform you on those events this year. I'm really excited about them. Cybersecurity Nonprofit has many programs and contents to help you. We have blogs on our website on a number of topics such as threat hunting, ChatGPT, cryptography, incident response, privacy, capture the flag write-ups at all different levels, beginner, intermediate, and advanced. We also have careers resources to help you break into cybersecurity, about diversity and inclusion in cybersecurity. And we also have a really great cyber safety program, which helps increase awareness of personal cyber safety and security risks of private information and property. And we teach people who may not be technical how to protect yourselves online and how to protect your family. We have offered boot camps before, and that's something we'll offer again. There are many ways to get involved in Cybersecurity Nonprofit. You can volunteer with us. You can become a member. You can also submit a blog or give a presentation or lead a workshop webinar like this one. We could use your skills, whether you're technical or not. We have all kinds of, I know for a fact that there is a role available right now. So if you're interested, please check it out on our LinkedIn. You can also donate to Cybersecurity Nonprofit, sponsor us, and partner with us. And all of that information is on our website. I'm going to leave this slide here for a minute so that we can thank our sponsors and our partners. Donations from our sponsors allow us to continue to host high quality events like this one. We have a variety of sponsorship opportunities, including providing venues, hosting events, becoming an annual sponsor. We also offer varieties of partnership opportunities with different benefits. So we would like to thank all of these sponsors and our partners here and welcome any more. So lastly, thank you so much, everyone, for attending. Here are all the ways to contact us through our website, through Meetup, LinkedIn, Instagram, and Twitter. We really appreciate your involvement and any feedback you might have. And again, feel free to look at that available role on our LinkedIn, and also stay tuned for more webinars, more blogs, and more interactive events. So I'm going to introduce Andy. Let's see, am I still sharing? Okay, so now I'm going to introduce Andy, and then let him start his presentation. So we're really excited to have Andy Murray present with us today. Andy has his CISSP, also a PE professional engineer. He is a 20+ year consulting engineer in the SCADA and communication field for electric utilities. His career highlights include the Y2K system impact studies, if you remember Y2K, design, programming, and commissioning of SCADA systems for electric municipals, substation communication projects, incorporating cybersecurity into existing systems, and training utility personnel on substation operations and protection principles. His more recent tasks have involved management of compliance programs, including NERC Critical Infrastructure Protection for multiple municipal electric utilities. Mr. Murray recently completed his Master's of Cybersecurity, Cyber Physical Systems concentration at Georgia Institute of Technology, during which he interned at the Pacific Northwest National Laboratory. There he investigated the application of zero trust in electric vehicle charging infrastructure. Andrew is a registered professional engineer in Massachusetts and holds Certified Information System Security Professional certification. So thanks for joining us, Andy, and I'll let you take it away.
Great. Thank you. I appreciate that introduction. I'm going to share my slides here, hopefully, and get started. Okay. Can you see the slides okay?
Yes, I can.
Great. So today we're going to talk about how the electric system is controlled and protected, mainly with the focus on the some of the cybersecurity aspects of that. So that introduction was great, so I won't talk too much about myself there. But the agenda will do a little bit on SCADA systems and what they are. Then we'll talk a little bit more on the cybersecurity aspects of it. If there are questions, please, if you could just post them into the Q&A, and I'll check in with those as we go. Like to make this as interactive as possible. So if there's anything you have a question on the slide, or if I'm trying not to use too many acronyms, but I'll probably forget that. So feel free, if I say something that doesn't make any sense, to post a question and I'll stop and explain it. So the SCADA primer, this picture isn't me, but the first SCADA system I ever did was actually replacing this system. Sort of wish I had kept at least a light pen or something. Would have been a cool thing to have. So some terms when we get started here. So SCADA is an acronym for Supervisory Control and Data Acquisition. Also, there's ICS, Industrial Control Systems, or Operational Technology, OT. There are also other systems that are very similar, and I may sometimes use their terms as well, but there are some slight differences. So there's like a DCS system, a distributed control system, is typically what you would have in maybe a manufacturing plant or a generating plant. Distribution automation is, again, in the electric sector, but is typically around switches in the distribution, so the neighborhoods, for redistributing power if there are outages and doing that automatically. Then there's also programmable logic controllers, remote terminal units, outstations. We'll talk about those. Those are sort of end devices that'll be part of a SCADA system. So just a little bit on the basics of electricity. So first you have the generation, so large scale generators. It might be natural gas, nuclear, hydroelectric dams, hydro storage. And typically the power there is generated and then stepped up through a transformer to the transmission towers. So then you're transmitting, usually here I'm in the northeast of the US, so we're usually somewhere between 115 kV and 500 kV, some places maybe even higher, but you'll transmit from those generating stations through those towers that you'll see sort of on the, usually maybe on the side of like the highways and things like that. And then that will get brought to a substation where they'll again have transformers that'll step it, excuse me, down from that 115 kV to maybe 15 kV or 4 kV. And then from there, you would have it go down maybe your streets in your neighborhood and to the poles. And there you may see like those smaller transformers. They almost look like trash cans on the top of the poles, where the power gets stepped down further to the 120 volts or 240 volts that you may have in your house or at a business. One thing I wanted to touch on is at any one of these stages, you could also see the distributed generation that is becoming more and more prevalent in the electric system. So you could have power plant size 100,000 megawatt units that are either solar or wind. Then you also see them especially in the work that I do, we see them more at what we would call a substation sized or level, where it connects in at that substation and it may be several megawatts of load. And then you also could have that same type of equipment down at the customer level. So some of you on the presentation today, you may have solar panels at your house, or you may have the Tesla power walls for batteries. And so you could have that down at that distribution level. Another thing that I want to touch on with the electric system is protection and controls are typically described as mature technologies, and I'll probably bring this up several times during the presentation, but this equipment is expected to be, in service for 20 years, maybe longer. So the change in technology is slower for a couple of reasons. One being, you're looking at 20 plus years before potentially you'll need to change something out. But also you have to make sure that you're picking something that you're confident will be, have a lifespan of that 20 plus years and be maintainable for that 20 plus years. Also, another thing that sometimes we'll see with the decision on which technologies to use, whether that's in the hardware, the primary equipment, or even the communications, the SCADA systems, the cybersecurity decisions, is interoperability and consistency. So especially with the way that the systems operate, oftentimes one of the big considerations is keeping it consistent through at least that utility or that entity's space, so that if someone's going to operate at station A, it's a similar methodology. The switches look the same, the layout's the same, the devices are similar. Because again, I mean, at the end of the day, the biggest thing is safety, and having people being familiar with the equipment, that obviously helps in one way with safety. So also when you're making changes, so if you did go with a new technology, and it turned out 3 or 4 or 5 years from now, it was a bust. You trying to replace that equipment, not only just the equipment itself, but do you have a second substation that you can move all your electric load to for a month while you swap out these devices? So you'll have that come up. Another term that I wanted to go over that might come up during these discussions is relaying. It's a real general term that we use for the protection of the equipment. I guess the best analogy I can give is, we're probably all familiar with the circuit breakers at our house, and your circuit breaker has both the mechanical interrupting, so it opens up the circuit when there's a problem, as well as the smarts, if you will. And I understand probably circuit breaker is about as unsmart of a device you could get, but it has the ability to do the sensing for there's trouble and it's going to open them. When you in the electric system, those two functionalities are actually separate. So you would have circuit breakers or distribution reclosers, sometimes we call them, different devices. But those devices in themselves would just do the mechanical opening and closing. You would have these other devices called relays that are going to watch the system and go, okay, I'm seeing more current than I expect, or that seems like the voltages are swinging too high and too low, and those make the decision to then tell that circuit breaker to open or close. So I just wanted to touch on that. Like I said, I think it'll come up in some of the other slides. So the Purdue model is a model similar to, say, the ISO model or the TCP model that we're probably all used to in computer networks. And it's used oftentimes to discuss SCADA systems or the OT networks in general. It's helpful so that we can all talk about things on a similar level. You also come across it pretty often in the frameworks or best practice documentation. They'll oftentimes give advice based on the Purdue levels that the equipment is at. And so I'm going to use this model throughout the next few slides to describe the equipment that is part of a SCADA system. So the level 1 or level 0 would be what I call field devices. And so we'll have what we typically refer to as smart devices. And again, smart devices maybe should be in air quotes, because what this is for a smart device compared to the latest technology on a smartphone, or what you can get in cutting edge technology, is definitely probably worlds apart. But anyways, these devices typically not only do the mechanical operations that we need, but they also have communications built into them. So it may be that the item there on the top left is a control switch. So not only could you use the handle to operate the device mechanically, but we may be able to send it signals to say, okay, we need you to open, and hit the switch, and the switch will open its device through messaging. You may also have meters that will connect to the electric system, monitor the voltage and the currents, and then translate those and put those into a protocol that then comes down across the SCADA system. And you may also have the blue box there in the center. That's an example of a relay, like I had mentioned a few slides earlier. And so with this device, you have the digital electronics inside of it to do that monitoring, checking the system. The engineer would program it to watch out for certain conditions and then operate the device, whether that's, again, a circuit breaker, or it may be talking to several other relays and confirming, this value seems out of range. Do you have the same value out of range? And all of that would be communicated over communications to, again, some of it to the SCADA system. Maybe we're getting status of the relay, what the relay is seeing, also communications to other devices. So again, another relay to another piece of equipment, things like that. Also, and you can see here a little small, but in the picture, there's the red and green buttons in the bottom right, this device may also be able to be used to control the breaker that it's monitoring. So you could use those to trip or open or close that device. And then we also have legacy devices. These would probably be referred to in the Purdue model as level 0. Things like it could be a discrete contact. Oftentimes that's how we still get the status of a circuit breaker or a switch. The device would have obviously primary contacts that open up at that 115 kV level. And then there's a smaller low voltage contact that follows that would bring that status into SCADA. There may be thermocouples or temperature sensors. Still have analog meters in some installations where that meter might be connected to a transmitter that's putting out a 0 to 1 or a 4 to 20 milliamp signal that has to be brought into the SCADA system. The next level up, level 1, would be the data concentrators. So here, this would also be an RTU potentially. And these devices would, in say a substation application, this device would talk to the other devices and concentrate the values so that the SCADA system would talk directly to this device and get, one big group of data as opposed to individual. So these systems, even the ones that I put in today, most of them now are Ethernet based from these two down to the meters, down to the relays, but there's still definitely a lot in service using serial communication. So for 2-wire setups using RS-485 or RS-232. Even some applications where we're still using dial-up modems to talk in between the devices. Another thing that we see more and more now is because of these smart devices have communications built into them, you may not need that central data concentrator. You may have these devices just Ethernet or fiber direct connection into the network. And then from here, your SCADA system can just monitor them directly without that intermediate data concentrator that we were used to seeing in a more traditional SCADA setup. Just going to pause here, see if there's any questions. Looks like there's a question. The slide decks. Yeah, I can definitely provide the slides if someone's interested in them, no problem. Thanks for the question.
And in a few days, the slides and the recording will be posted to our website, so you can find it all there.
Great, even better. So the next level, the server level, would be probably the Purdue 3. And the reason I put an asterisk here, probably you're used to seeing this also when you're dealt with, say, the OSI model or the TCP model. The levels that are defined almost never exactly match what your system is set up as. So you could have, and I think I've got another slide where I can show this even better, but you may have some devices that maybe it's on a level 3, maybe it's on a level 4. So that's just sort of the reason for the asterisks. But again, at the server level, SCADA systems, the ones that I typically work on are smaller. So it may just be one SCADA server, which is really just some Dell desktop, or 2 for redundancy. Further or bigger systems may have redundant, not only the redundant servers, but they may separate out functionality. So they may have a server that is the database. So the real-time data from the SCADA system goes to one server. Then they have a separate server for a historian where the subset of that data is being logged, especially the analogs. You could have a separate server that's also doing alarming. This is most often now systems are virtualized. So, I am seeing most of the places they're doing virtualization, but we still see most of them putting them in as dedicated machines. So they would have, a bare metal machine somewhere that's the SCADA server, but it may have multiple VMs on it, or at least even in the cases where we have a small system where the SCADA system does all this functionality in one, they'll still do it as a VM because people here on the presentation probably know VMs even better than I do, but the ability to do the backups and the recovery, it's just much simpler using that technology. And also more and more with the bigger systems too, you may have these these systems using data or sharing data with others. So maybe the SCADA server is a dedicated machine, but the historian is something different, or that's a shared based system. There's also SCADA as a service or cloud-based SCADA. There is a lot of this in the industry from a, I guess, services point of view, like people selling it. I haven't seen a big uptick in usage yet. I suspect it is coming. I do see a lot of cloud-based systems that I would say are like adjacent to SCADA. So as an example, another big digital transformation in the electricity industry is automated meter infrastructure, or AMI, which is essentially the ability for the utility to read the meter. So like the one that's on the side of your house, you probably have a round one, looks almost like a Tupperware or something stuck on the side of your house. Those are now almost always read remotely, usually in some sort of mesh network setup, probably using cellular or Wi-Fi or unlicensed radios. A lot of those I've seen are going into a backend that's cloud-based, and then the utility is accessing that, like you would expect. And again, I got to be honest, I'm not a cloud expert, so there's probably, again, people here who could explain that in better detail, but I am seeing that. I suspect that we will see the whole SCADA system go to cloud, but right now, I mean, one of the things I think I touched on is the fact that the electric industry is, very reserved, looking for things that are going to be redundant. And one of the things that places I see that a lot with SCADA systems is keeping the SCADA system in-house. So I think that's one of the biggest reserves to doing the cloud-based, is people deciding, do they want to give up the control of their SCADA system? Obviously, for this audience, people understand, there are a lot of benefits to having it cloud-based, where that there are people who are monitoring those systems, whether it's the hardware, whether it's the cyber. But again, the industry itself is slow to, go to changes for, essentially making sure that it's something that we can trust and we know will not only serve our purposes, but also be there long term. So then you have the SCADA or the HMI displays. The top display here is the typical display, at least for systems that I design and work with, what we call a one-line display. Terminology comes from the fact that these white lines here represent the primary electrical system, which is often 3 wires or a 3-phase system, but it's drawn as one because all 3 of those wires would go into each piece of equipment. Those squiggly lines that you see sort of towards the top middle area, those are the symbols for transformers. And then the devices in color, so the red boxes or the green outlines, those would be our symbols for circuit breakers. Red solid being a closed breaker, green outline being a open breaker. And then you have some analog values there. I think on the slide it might be a little tough to see, but you've got some voltages and some amperages readings. There's also common screens that just mimic the field device itself. So these 2 in the lower left and right corner would show the device itself. And these are nice when you have opportunities where you're using the device not only through a SCADA system, but also you be interacting with it in the field. So sometimes it's a little easier to remember where things are, how the menus are laid out, where the data is, because you see it both on the SCADA screen this way, and you see it that way also when you're going up to them. Other displays that we often have in SCADA systems would be trending. And the trending screens would be in systems that I typically build. It's all built into the same software, so they would have a trending feature in it. More and more with larger systems, you would have a separate trending system, part of the historian I had mentioned before. There are other systems where it will store data and you just output it and you do all your trending and your analysis in Excel or some other data viewing system. Also, alarming is another main function of a SCADA system. So you would have that either built into the SCADA system, where you have screens like here in the bottom half of this slide, where it would list the element, the little more descriptor of what had happened, the on and off time when when the alarm had gotten acknowledged, things like that. Both these pieces of data are very oftentimes then put into some database in the back end so that that's stored, logged, and then you can use your system to look back. Obviously, with trending, you need to store that data to look at the history, but the same with the alarming. What we do see with more larger systems where they put these on separate software to do this is oftentimes they'll integrate it with other programs. So maybe it's alarming that's not only from SCADA, but maybe there's building alarming coming in, HVAC alarming from maybe the metering system or other things like that. So they have one alarm package that does all of that. Same with trending, that's often to see. Again, I see that more in a larger utility size SCADA system than in the smaller municipal markets that I work in. And then just pause here real quick. I don't know if I don't see any questions, but if anyone has a question on any of the material we've done so far. Okay, looks good. So the SCADA network, and I don't know if I'd mentioned this before. So a SCADA system is typically, I guess you would refer to as a wide area network, being that the system is expected to communicate with substations, whether it's a small municipal that I work with would at least be 1, 2, maybe 3 towns that they cover. So then you're talking maybe it's 2, 3, 4, 5 different locations. You could have pole top devices. So the SCADA system would be a geographically dispersed system, as opposed to like a DCS system, another variation where that would be expected to be in one plant, in one building. And then, even though the entity may own several generating facilities, they have the DCS system for this one, a separate dedicated DCS system at the other plant. So these networks, the gold standard would be fiber between all of these locations, but fiber is expensive, so not always the case. Though one thing that the utility does benefit from is, especially the municipal utilities, because they're part of the town, oftentimes they will do a town-wide project for fiber. There are also some utilities that we work with that are internet providers for their towns. So they'll have put in a pretty robust fiber infrastructure to do that functionality. And then basically we get to use it for our SCADA because it's there. In instances where they don't have that, I would say the second most often method is radio, whether it's dedicated leased or owned licensed radios or unlicensed radios. You'll see that a lot. There is cellular modem options where you can set up private networks. I've seen that. Mesh networks is more common, more and more now, especially like I said, the AMI systems use mesh networking. I haven't seen it too much in the SCADA systems themselves. The distribution automation a lot of times uses mesh networks to talk to each other. So just to tie it all together here, I just want to show a quick slide of where the levels in the different devices would be and how they would all tie together. One thing I don't know if we did talk about is the DMZ, where hopefully, cyber people, we hope that there is a robust firewall or firewalls between the OT or the SCADA network there, which in my diagram here is maybe those bottom 4 levels, and then your upper 2 levels. And that firewall is there for applications where maybe you're pushing data to that centralized server. Another very common application is they want to have SCADA access to their operational personnel remotely. So you may have an on-call crew who needs to know, okay, there's an outage, I can access the SCADA system, it'll tell me this circuit breaker opened, these alarms came in, things like that. Common now for SCADA systems to also be tied into the ability to send remote alarming. So whether that's email, text, apps, things like that. That's common. I have seen SCADA systems that actually include their own apps to be run on like iPads or phones. Not something I've implemented or seen clients actually use, but I know that is a feature that's in the industry. So the SCADA network protocols, I would say there's generally two types of protocols. There's the real-time data, so I guess the SCADA protocols. So the ones that common used in the electricity industry are Modbus, DNP3, IEC 61850 is a newer protocol. There's also still proprietary protocols that sometimes we use to talk to different devices. And then there's the ICCP is a protocol for talking between control centers. So this you would more often see in larger utilities to either talk between their control centers or so that utilities in one area can exchange real-time information with maybe the utility in an adjacent area. So again, if you have wider area outages or you're starting to see system issues, you can pass that messaging on quickly to the other utilities that you interconnect with. Also on these networks, oftentimes you'll have engineering access. So those could be FTP, Z modem for file transfer, HTTPS, Telnet, SSH into the devices. And this is one of the areas where I think the cybersecurity is becoming, I guess, an area of concern with new smart devices in the industry. Because as these devices come, I wish I had a term for it, but more smart, and we get them with these other built-in protocols to provide other functionality, whether it is that meter or that relay that can also give its data directly to SCADA, but also has a web interface so you can program it, or it allows for FTP to download event records. You know, we all know the amount of vulnerabilities that there may be in this FTP client or, you know, that version of encryption. Something that I don't know if I touched on was, and maybe it's, I think I have it in a slide coming up, but, you know, we talked about how these devices are put in for long lifetimes. So your relay or your SCADA system for 15, 20 years is what's expected. Well, we may not be as diligent as our IT counterparts in doing updates to those, or we may not have the ability to do updates as quickly as we want. So maybe that device I bought 10 years ago that has FTP in it has a, you know, FTP stack from some vendor who may not be around anymore, or hopefully they are, and maybe they found a vulnerability and they did right disclosure, you know, or another smart person on this call here, maybe you've, you know, discovered a vulnerability, did the correct disclosures, but then did that message get down to the utility who has that device? So that can be a concern sometimes. So I just want to quickly show a little bit more information on these protocols. I apologize if the slide's a little hard to read. It's a bit of data here, but the Modbus protocol is, I guess, very mature. Was designed initially for serial and serial at 1200 baud speeds, so very low overhead. But like most of the protocols that we see, at least the mature ones such as this, it's all in clear text. They do now have, and have for a long time, have TCP versions, which is mainly, it is a slightly different version of the protocol, but it's mainly the serial version with TCP wrappers put around it. But in the message, there will be these function codes, which basically will tell the end device or tell the SCADA server what kind of message is here. So maybe it's a function 01 here will allow you to read coil statuses. So that will tell you, the SCADA server may send that message down to a device and say, tell me, are all your 3 breakers open or closed? And it will send back binaries for each one of those, that it's a 1 or a 0 for open or closed. There may be another one for reading the analog values, things like that. The other very common, and I would say this protocol now is probably the most common in the electric industry, more so than Modbus, is DNP3. Also a pretty mature protocol, but built a little more robustly than the Modbus, a lot more features in it, though still initially built for the serial links, most often a 9600 baud link or higher. It also has the TCP method, so you can do DNP over TCP, and that's probably most of what I see is the TCP version of DNP, but it's set up very similar. The one thing about DNP that's a different from the Modbus one, Modbus is basically a polling in reply setup protocol. So the SCADA server would have to poll the device will send back its data. If the SCADA server doesn't send a message, the device would just sit there. DNP is a little bit different in that it has different ways that it can report data. It can do that poll and response, or it can do what they call a polled report by exception, which is meant so that the field device, when you create the data points in it, you put them in groups in what we call classes. And you also set band on them, or dead bands as they call them, where if this analog value goes up by more than 2 amps, then I want you to respond back. But if it doesn't go up with them for more than 2 amps, when the SCADA server asks for an update, you just say you have no update. And you can probably tell that these advantages to the protocol were more meant when you were constrained with bandwidth. If you have a fiber connection out to one of these devices, you could poll for every point of data as fast as possible, and you'd never come anywhere near your bandwidth constraints in fiber. But also have what they call object groups in DNP, but very similar to the function codes we talked about in Modbus. So you'll have ones for binary inputs, but you can see like with DNP, it does have methods for file transfer inside of it. It does have the ability to do time syncing built into the protocol itself. It has these things called IIN bits. I think it's internal indication notifiers, where like one of them would be the time needs to be synced, or another one may be I have some of these event daters. Another one can be if the field device comes offline. So if there's trouble out at the field device, that can come back built into the protocol, as opposed to you having to create a separate data point that says, this device is having issues or something like that. DNP, Modbus and DNP are still actively maintained protocols, but DNP is, I would say, more active. There is a new addition to DNP. Well, new, it's probably been around for, maybe it's even been 10 years now, but one that they've updated. And I know they came out with a new revision very recently, where it's DNP SA, and the SA provides some authentication, message integrity, and encryption built into the protocol, though it is getting very slow response in the industry to bring this online, unfortunately. I think I have seen maybe 2 or 3 of the devices that I typically use in a regular system that have this as an option, and I don't have a system yet that actually uses the protocol actively. I just want to show quickly a DNP Wireshark example. Like I had mentioned, it's a clear text protocol. There are Wireshark decryptors, or not decryptors, but they do have Wireshark's ability to interpret DNP, Modbus, a bunch of other protocols that are used in the industry. And so you can see here, it'll break it down for you. You can see exactly what's coming across. You could even see which bits were set, things like that. You can see where I use Wireshark a ton in the field, and you can also see where for cybersecurity, there could be a lot of pluses and minuses to having this ability so easily built in. So then I'm just going to go on to the cybersecurity aspects, but I'll pause here again just for a second to see if anyone had any questions or if there were any discussion points on what we've talked about so far. Okay. So IT versus OT, this is one of the big topics when you're talking about cybersecurity for OT systems. There are a lot of differences, and you can see this is a table of some of those. Like availability, some standard would say maybe that in IT you can tolerate some delays. I know that there are some protocols where it's meant so that if you lose some of the packets, it is ways of capturing them back up. In OT systems, depending on the usage, it's expected to be up 24/7. The data streaming all the time. Sometimes the protocols are deterministic and need their data constantly. And this is one of the things where it depends on the OT industry or the OT system you're talking about. The electric utilities, and especially the systems I work on, I would say are even probably less time sensitive than your standard IT. And the reason I say that is our protocols are being scanned on a seconds to 10 or 15-second intervals. So obviously in there, especially if we're using Ethernet, we can do lots of retries and retransmissions, and you'd never notice the difference. The other reason I say that is SCADA systems are, for all their great use and how much the utilities rely on them, utilities will have the ability to run their system without SCADA at any time. They have manual controls for everything that SCADA does. I mean, the one thing that maybe they would lose is their data analysis. So they may not have that, but you can go down and write down values. They would still have meters that display those values, so that value would still be accessible at any time. So that's the reason why I say this table, each one of these items we could probably discuss, it applies here, it doesn't apply here. This table is right in this instance, not right in that instance. And I completely agree with anyone who want to point those out. Cyber maturity, I would say, is much higher in IT. OT, I was looking to a webcast the other day and someone mentioned that OT, maybe you could think of it as being 10 years behind in what you see in the IT networks. And I would say that's as good of a estimate as any. I think you've heard me talk about, this, what we use now, and all of that is very, very, old school when it comes to the IT systems. Another part where IT and OT differ that I wanted to talk about was the device network robustness. And in this instance, what I'm thinking of is when you can do testing, not so much that you can, and I think we would all agree, you shouldn't be doing any sort of fuzzing or any sort of network testing just when you want to on any network, except for maybe, some little network you have at home or a test lab. But I think that in general, IT equipment that we have, our Cisco switches or our, latest laptops or cellular devices, they would withstand those, those packets, those odd messaging much, much better. And again, you may end up clogging up the network. The device may stop communicating while you're sending a ton of packets or something like that. These days, probably what you would do is you would set off a ton of alerts in your SIM solution or something like that when you do these tests. But on the OT side, there's a real possibility that you could end up taking devices offline. Obviously, there's also a real possibility that because that system is meant to be running all the time, that again, you never want to do this just because you want to see what's out there. I mean, you would need to make sure that, everyone's on the same page. We're doing this, the network's, accessible, things are maybe taken off the SCADA and put on manual, things like that. But besides that, when you would do this testing, there is a real chance that you could get these devices to lock up very quickly. I haven't so much heard of them completely bricking a device doing this, but I myself have done some fuzzing just on my own devices I was able to bring home. And I can tell you, I did some, and I got a device to lock up several times with sending odd Ethernet messages. I got another one to lock up when I sent a FTP password, even though it was the wrong password, but a password that was greater than, I think, 15 characters caused the thing to lock up. And like I said, in both those cases, you rebooted, it came back. But just to give you an example of what I was trying to point out there. So IT and OT systems really that different. This is, again, a really hot topic discussion with cybersecurity and OT systems. And depending on who you ask, the answer is going to be very different. I don't disagree that they are very different in the things you can do, what they do. But I guess what I would say is that I don't think that that's a reason why all the OT systems or the SCADA systems should be kept at arm's length from the IT department. I think if you know your system and you're conscientious and consider the consequences of how you're testing your system or what the system is made of, you involve stakeholders when you're looking into, any type of work, and you have a plan and you work that plan. Another interesting thing about OT for some cybersecurity is we actually have some cases where we have out of band methods for protections, so that if I think we talked about it a little bit with the SCADA system, if the SCADA system goes down, all that functionality, at least the core functionality, the utility can still continue, no problem. But there's also cases where we have equipment that you may be able to set where it could monitor the device, like I was telling you with the relays and things, where if someone tried to get that device to do something completely out of bounds, that even though that command came through, went over the network fine, the device took the message, your other protection said, this message makes no sense, or you can send that message, but because condition A, B, and C are not met, I can't do that operation. And this is actually becoming more and more widely discussed topic. I think the official term for it is cyber-informed engineering. I know that the DOE has a lot of information on how to work in cyber-informed engineering. I think it was actually also brought up in the latest White House release of our national, at least in the US, the national cyber strategy, about doing more of this cyber-informed engineering. Cybersecurity vulnerabilities, there are definitely vulnerabilities in SCADA systems or OT systems, just like anything else, and depending on who you ask more. We talked on the protocols, they are in the clear, insecure, most of them. So you're looking at putting either some sort of extra wrapper around your devices to provide encryption, or having to do other things outside of the maybe the SCADA commands to protect the network as a whole. The expansion of things connected to SCADA, I think I touched on this a little bit earlier, but you've got not only the smarter devices, but you may have these other systems. So AMI also connecting to SCADA because you want to share some data, or maybe you have other customers, big customers. So the solar sites we talked about, maybe you're having the solar vendor connect to SCADA because you want to know what's the solar site running at. Are they online? Are they offline? Well, that's great, but now you've got another entity that you have to make sure you're protecting the values and the data that's coming from them. They have a connection into your system. There is physical access to most of these devices. All of them are locked. I'm sure you've seen, or maybe after this talk, you'll notice them now. There's cabinets on poles throughout any distribution system. And inside those cabinets, they'll be padlocked, but inside there is some controller. Probably has a radio or an Ethernet connection right there. There's obviously no one there protecting it 24 hours a day. Substations are very similar. They have robust physical security, locks, fences, cameras, but there's no one there 24 hours a day. So there is, that's a huge potential risk there. And then we talked about the long lifetime of the equipment, and sometimes the inability to do updates, or the limited amount of updates. This is, I think, another place where trying to get some ideas from IT and merging them into OT is going to be a great asset of how do you do updates on these systems. They're very similar in your update strategy as you would have an IT, but they're a little different. They're a little more critical. So you just have to, I think, come up with a plan. And I guess as a good example, when I talked about those small SCADA systems, they're run on Windows machines, but you typically won't connect those machines direct to the internet. So you can't just let Windows run its regular Windows updates and just let it handle it. You need to either create, what I've seen a lot of is they'll create a, I think the term is like a WSUS server, where you have one machine, maybe in the DMZ, that pulls down the Windows updates. That will then be pulled by your SCADA system. I have one system that's completely air gapped, which is another very highly contentious term in the industry, but where the system is only connected to the 3 SCADA computers and the field devices. So once a month, I go on site with a USB stick, Windows updates, install the updates, install software updates. So sometimes it's done that way. So like I said, I think the cybersecurity vulnerabilities, or how to address these vulnerabilities, is a place where it'd be great for the IT and the OT folks to really get together. So I just wanted to quickly show this video of a test DHS has done. And if someone wouldn't mind, I'll start it here if it doesn't play through for you. There is no sound, so you don't have to worry about that. But if you're not seeing the video, if you could just write it in the Q&A, I appreciate that. Thanks. So basically, this was a test. You can see quite old now, but that the Department of Homeland Security and one of the national labs did, where they basically mimicked a cyber attack on this generator. That was the big green machine there is a generator. And then at the beginning of the video, they show you the switch gear, which is where the circuit breaker that sort of allows this generator to attach to the electric system. And what they were demonstrating was if you could get access to control that circuit breaker, you could, that shaking that you see of the generator is whenever they would close that generator right back into the electric system, it would make that generator shutter like you see. And basically what's happening is when you connect a generator to an electric system, you need them to both be what we call in sync. So not just my favorite band, but you have to have the AC models match so that you have the system, the electrical system, on the same speed and the same frequency and at the same times as the generator. And when that doesn't happen, you see what happens here. You can have a very catastrophic failure with the generator. This was a very interesting and very big deal in the industry when they first came out for several reasons. Not only the shock factor of, okay, here's some worst case scenarios for cyber attacks, but it was also one of the hot topics in the industry because this is a case where we have out of band protections that would make this scenario a lot more difficult. We have on every generator system, you would have what they call sync check relays, whose whole purpose is to make sure that when it's called for to connect the generator to the electric system, that the two systems do align and you don't have this mismatch that could cause this type of a catastrophic event. And those relays are there long before cyber. They're meant for, maybe I make a mistake when I tell the generator to close, or if I'm doing it even automatically, we have the second step because this is what could happen in, we're talking millions of dollars of equipment here, and you don't get a generator like this, down at Home Depot when you blow up the first one. So, but I guess the scenario that they may have here, is that maybe the system is very interconnected. So you got access to the circuit breakers, you also got access to the relays. So, it is definitely a viable possibility. And I think a great example of, one of our worst case scenarios. So the cyber protections, just to touch on those, some of these we've talked about. The physical network isolation, which is less and less these days, but the out of band measures, which we just, again, talked about in detail. You may have dedicated SCADA personnel. More and more now, you've got those OT personnel and also dedicated SCADA security personnel. There's much more awareness for cybersecurity in the industry. There's a lot more compliance and regulations as well. And there's more and more now solutions. There's dedicated companies for ICS cyber. There's dedicated hardware and software solutions just for the OT market. So there is a lot of that helps. A couple of other OT events I want to touch on, you may have heard of. There was one in Florida a few years ago where someone looked like they got access to the water treatment control system or the SCADA system, and they were able to essentially, I believe, they thought they came through TeamViewer, and the operators saw the mouse move. Someone go take the mouse, go to a value, change it. The operator saw it quick enough; they were able to change it back. Interestingly, this story I saw there was an update very recently where they think actually that may not have happened, and it could have been actually a manual operator error that it somehow someone had turned into explaining it as a cyber event. But either way, I think it is a possibility of something that could happen. We've seen several cases in the Ukraine with the war in Ukraine where they've attacked the electric system, cyber attacks. Another incident that I just quickly mentioned, because I like to use it as an example when I talk to my clients, there was a municipal here in New England where they got some malware on one of their desktop computers, not the SCADA system, not anything like that. It was just a ding from their Norton or McAfee, caught it, no problem. But in doing their due diligence, they reported it to the utility oversight for the state. They reported it to the local FBI, and it got leaked to the media. So then there was articles that the XYZ municipal had been hacked, that the electric system was under cyber attack. So it was unfortunate the way that sort of blew up. Standards, I had mentioned these. The big ones are NERC-CIP. And so what this is government requirements that we have to follow in the electric industry. Specifically, these ones are required, I guess, for larger utilities. So most of the municipals that I work with will not have to meet these, or may only have to meet one or two out of the, I think there's 14 now. But they are used oftentimes as guidelines. And we're also seeing where they push them further and further down. So I do expect that as time goes on, there will be revisions to these where what they call the low impact entities will be required to meet more and more of these. I see there's a question come in.
Yes, so we have a question. Can you touch on how common data diodes are and or common logging from SCADA systems controls for security analytics to a SIM, either devices or decoys or compliance?
Sure. I can just tell you from my experience, I've seen none. I've heard a lot about data diodes. One of the big players in the industry is Waterfall. I think it's Waterfall Industries. They're one of the major manufacturers of data diodes. So if you are interested, they've got a ton of white papers, and it's been around. It's a pretty mature technology, and I know it is used a lot in OT, but I think the applications are larger instances. And what a data diode is if you think back to that diagram I had of the network, you could put that data diode between the OT and the business network. And what that would do is allow for traffic to only come from your OT network out into your business network. And it's a physical type of device that does this. I believe they do it, maybe each one's a little different, but they do it with optics where it can only send messages in one direction. And then I think they rebuild the data on the other side to be able to still pass it on as TCP or UDP. But those are a great, idea. I don't have any personal experience with how much it's used. Also getting the data into SIM solutions and things like that. I know, again, it's a very common topic in the industry, and I think it is done a lot at the larger utilities. One thing I have seen at the smaller utilities is this type of thing, but as a service. There's a company, I think it's Dragos, who does this. I was actually just hearing it on a webinar the other day. I think it's called Neighborhood Keeper. And what it is they have these, I think they're some sort of a network appliance where they will put them at strategic spots in the SCADA network, and it will take the data and pass it back to them for analysis to look for any sort of attacks or anomalies, and then sort of a way to outsource that SIM type functionality to the investor owns. And this is one thing, I'm sorry, to the utilities. This is one thing that I really would like to see and hope that with the with some of the standards as they change, and also with the government funding and things that they're looking to do, that we'll get more and more of. I think the monitoring part is a piece that we could really gain a lot in that isn't being done now. I think there is a lot of look at cybersecurity when devices are put in. So designing the network, thinking about having the protections, virtual private networks, things like that. But I think more and more that's done, and it's almost a set and forget it, and not as the maintenance or the, like we were talking about, the updates and monitoring, logging, things like that is a place where we could definitely use more. I did want to talk about some of the more cutting edge, for the term that I would use, that there is in the industry, because I know I probably make it sound like nothing in power has changed since 1950. There's a one of the protocols I think I touched on was 61850, is common used in this application here, where you basically have what they call these merging units out at the major primary equipment. This gray device here on the left, that's a transformer, and then the one next to it would be a circuit breaker. But you would have these merging units that will take all the data from these devices, the voltages and current sensing, the controls, put those digitally, typically over fiber, onto what they call the process bus. The process bus would also have satellite or IRB clock signals into it, so you can have super precise measurements. And then that data getting pushed into the relays for them to use, and also pushed further into your SCADA and your HMIs. And an extension of this that's even newer now, this was actually something really interesting in one of my graduate classes in the program I just recently finished, where you would have the same thing, but you would have substation computers that are monitoring this data and can actually do analytics on the data real time to judge if any of the data looks like it's out of bounds. So it can find that one of these analog values, potentially one of the currents, seems to be out of range. And it can do it not only well, in the speed that these relays are still expecting, that, millisecond resolution, but it can also then determine what it calculates the value should be based on the rest of the values that it knows are good, and substitute in that value. Now, this could be probably the most common instance of it is just the device is failing. The transducer or the device out there that's creating those amps or voltages is failing. But it's also been looked at as a way of catching potential cyber attacks. So if someone was able to get onto this process network, and you wanted to, make that transformer or that device start to misbehave, one of the best things you can do is fake the data, so SCADA or the people watching have no idea that it's actually doing it. Well, the idea here is that hopefully with some of this analysis that they're doing at the that process bus level, they're going to be able to see that something's not right there because the math just doesn't add up, and catch those type of occurrences that way. More things that we're seeing is the distributed energy resources. So battery storage is really big now, wind, solar, increased electrification, where they're pushing more and more, especially at the clients for like the customers, for doing whether that's electrification of vehicles, electrification of heating systems, things like that. So your electric loads are getting much higher. So you're going to have more infrastructure just there. You're going to then have more control systems for these. So the batteries or, that electric vehicle controllers, things like that. You have the more interconnected systems that we touched on. Another thing that they're looking at potentially we would have in the industry is like an Uber for energy. So instead of you buying your electricity from that one company that services you now, maybe you can buy it from multiple different people. Maybe there's going to be a time when you can buy your electricity for your car from one person, the electricity for your house from another, and it's all done on an app on your phone. The other thing is, there's a lot more protections coming in. There's a lot more government funding. Right now, I know of actually one specific project aimed at smaller utilities. And they're right now, I think they're in the I'm trying to think what they call it, but the request for proposals or the requests for information from the utilities on what they could do to help them the most. But that's that's going to be a great help. There's also more research. It's becoming more and more of a topic of interest at universities. I think I had mentioned, it was in my the intro that they did, the program that I just finished had a cyber physical track where a lot of our example classes for the OT systems were actually the electric systems taught by professors. One of the professors wrote a book that we've all used at my company forever. He helped initiate some software that we use in the company all the time. So you've got these industry experts that are really deep into this, which is great. And then I think I touched on this, more and more cyber professionals, both organizations, and there's more people now looking at OT cyber. I mean, hopefully you're here at this webinar because it's something that maybe you'd be interested in. And to that point, I just want to give you some resources. Here's some sites if you're just interested in some more general SCADA information, some more on just the OT, the cybersecurity aspect of it. I would say, even if you've got the slightest interest in learning more, check out the CISSP website. They have a ton of all free trainings, a lot of on-demand trainings that you can do. If you can, they also do in-person trainings that are free. You're responsible for the transportation and stuff like that. I think they're still done at the Idaho National Labs. I went to this years ago. It was probably the best training I've ever done. I think I mentioned them before. Dragos has a ton of resources. SANS has an ICS security section, so feel free to check them out. There's a bunch of great podcasts. The book that there's a picture of here, I have that. It is a little like kids' cartoon book, but I brought it to work and left it on the lunch table so that all the other power engineers can hopefully learn a little bit more about SCADA. I think it is a great book. It's, I don't know, 10 or 15 pages long, but definitely something that I highly recommend. So that's all I have. I appreciate everyone's time. I think we went over a little bit the hour, but I appreciate everyone sticking in there. Here's my contact information. So should you want to reach out for anything more, if you have any other questions, feel free to ask them now. But if not, you want to reach out to me, feel free, or maybe we can, connect on LinkedIn. Again, I appreciate everyone for, attending.
Great, thank you so much, Andy, and thank you everyone for attending this webinar, giving us your evening when there's a lot of hockey games on right now. Andy and I both live in Massachusetts, so I will be watching the Capitals at Bruins game. Once again, thank you so much for attending. This recording and the slides will be posted on our website in a few days. Our next webinar is May 25th, and it's called Job Searching Like a Recruiter for both students and seasoned professionals. We got 2 questions coming in. So thank you so much, Andy, for the nice and very informative session. What are the Bolts? Who are the Bolts? Someone said, go Bolts.
Is that Tampa Bay Lightning?
Oh, okay. Can you please provide your website link? Simple, CSNP.org. I can give a few minutes for other questions to trickle in, but you are free to go. Thank you very much. Great presentation.
Thank you. Thank you for having me. I appreciate, again, everyone hanging in there and your interest in it. And hopefully you consider, if not, going into OT cyber, at least if you have the opportunity, reach out to people that you work with who might be on the OT side, because the better communications we can have between IT people and cyber people and OT people, it's going to be better for everyone.
Yeah, so do you think OT will catch up to IT?
I to be honest, I think we'll always be that, that 10 years, or I don't know if it'll be 10 years, but hopefully we'll be a lot closer in the things that matter. So we'll have cyber where, we're doing all the standards. I mean, one of the other things that I heard over and over in a webinar I was listening to the other day, or a podcast, they were saying, like, their example was, well, if you don't have your doors locked, you don't need neighborhood watch, or you don't need, and I think they were referring to like getting threat intelligence and stuff like that. But if you haven't done, a due diligence of, do you even know what all the devices are in your OT network? Do you know which ones need patches? Do you know what holes you have? I think those are the people that are, we need to take those steps first and then build on it. And I think that's where the compliance stuff that we talked about comes in handy. I mean, compliance is sort of a dirty word in a lot of applications, and I completely agree sometimes doing all the paperwork, but I think they're requiring the right stuff. We're getting people who can, they'll ask you those things about, what do you know what your systems are? What ports are open? Why are they open? I mean, that's a great beginner. Even for the places that do put in, like I said, a lot of people do VPNs in for SCADA remote access. Is, how are you doing that exactly so that you're only letting the SCADA, vendors in, or, the access, things like that. One example of that I actually came across, we had a client who had a device that was directly connected to the internet. Intentionally, they decided, it was easier for what they were doing, and it wasn't controlling a circuit breaker or anything big like that. But one of their IT department questioned it because they said, we noticed this device and it has a default password. And the default password they were referring to is the device had bought from another vendor, Ethernet to serial converter, and just sort of included it in the device. And sure enough, I'm not sure how they had done their inspection of it. I don't know if they had an automated system that did it, or if he just, pinged the IP and then looked up the header to say, oh, this is device by XYZ, and looked him up what the default password was. But he was like, can we at least change the default password? That's a great thing. Yep, that was a good catch, and that was a good thing to do.
Awesome. If there are no more questions, we're gonna, you are free to go. Thank you so much for attending, and thank you so much, Andy, for presenting with us.
Great. Thank you for all your help, Mar. Pleasure.
Thanks.
Bye all. Have a good night.